So now we have come to our last topic of matrices and also most important topic of matrices, which is system of linear equations. So from this topic, you get a question in JEE Mains every year, almost every year. So what are a system of linear equations? So let us take an example. 2x plus 3y is equal to 5. This is an example of a linear equation in variables x and y. Or this is a linear equation with unknowns x and y. So now let us take another linear equation in x and y. So let us take x minus y is equal to 2. X minus y is equal to 2. So this set of equations is called a system of linear equations. System of linear equations. If you have one or more linear equations as a system, we call it a system of linear equations. So these are a pair of linear equations. This system has two equations, so we can call it a pair of linear equations in unknowns x and y. Now instead of two equations, we can also have three equations. For example, x plus y minus z is equal to 1. 2x minus 3y plus z is equal to 2. X minus y minus z is equal to 3. So each of this is a linear equation in three variables, or each of this is a linear equation containing three unknowns. X, y and z are the unknowns. And you have a second equation, you have a third equation. So this three equations combinedly is called a system of equations. System of equations. So once you have a system of linear equations, we have something called the solution of this system. The solution of this system of equations. So what is the solution of the system? The solution of the system is nothing but the values of x and y. The values of x and y which satisfies all the equations in the system is called the solution of the system of linear equations. So the values of unknowns which satisfy all the given equations. All the given equations is called the solution of the linear system of equations. So you have already had some introduction of how to solve the equations in your lower classes. For example, if you have these two equations, these are pair of linear equations, you can solve them using any of the three methods that you know. That is the substitution method, elimination method and cross multiplication method. So if you use the elimination method, so you have 2x plus 3y is equal to 5. I'll multiply the second equation with a 2. So 2x minus 2y is equal to 4. If you subtract one from the other, you get 5y is equal to 1. This implies y is equal to 1 by 5. So you get the value of 5, you get the value of y. Once you substitute the value of y in the equation, so 2x plus 3 by 5 is equal to 5. 2x is equal to 5 minus 3 by 5. So 25 minus 3 is 22 by 5. This implies x is equal to 11 by 5. So what is the solution of this system of equations or a pair of equations? So x is equal to 11 by 5 and y is equal to 1 by 5. So these values of x and y satisfies the first equation as well as the second equation. Similarly, you can solve this system of equations also. So if you have more number of equations, the process becomes slightly involved, but theoretically you can solve these equations. and get the solution. Now, if you take a system of equations, for example, x plus y is equal to 3 and x minus y is equal to 2. So if you take a system of linear equations and if you solve these equations and get the solution. So if you get a single value for the first unknown and the single value for the second unknown, we say that the system of equations has a unique solution. So if you solve these two equations, if you add these two, you get 2x is equal to 5. So x is equal to 5 by 2. If you subtract these equations, you get 2y is equal to 1, y is equal to 1 by 2. So you're getting exactly one value for x and one value for y. So I say that this system of equations has a unique solution. Not all system of equations have a unique solution. For example, if you have x plus y is equal to 3 and 2x plus 2y is equal to 6. So if you have this equation. So as you can see, this equation has more than one solutions. This system of equations, these two equations will have many possible values of x and y. As you can see, if x plus y is equal to 3, this 2x plus 2y is equal to 6. So if you take a 2 as common, this equation will also turn out as x plus y is equal to 3. So effectively, this looks like a system of equations, but you have effectively only one equation in x and y. You have only one equation in x and y. So if you look at the solutions of this equation, you can have many different possible solutions for x and y. That is, if x is equal to 1, y is equal to 2, both the equations will get satisfied. X is equal to 0, y is equal to 3, x is equal to 2, y is equal to 1, x is equal to 3, y is equal to 0, so on. So you can have infinite number of solutions to this set of equations. So if there are more than one solutions, we say that it does not have a unique solution. So in this case, this system of equations will have infinite solutions. Next, it might happen that the system of equations has no solution at all. So if I say x plus y has to be equal to 2 and x plus y has to be equal to 3. If I take these two equations, so these two equations do not have any solution, because if x plus y is equal to 2, x plus y cannot be equal to 3. So this set of equations have no solution. So if you take different systems of linear equations, they can be broadly divided into three types. There are systems having unique solution, systems having infinite solutions, systems having no solution. Right? Now, the system of equations having no solution are called inconsistent system of equations. Inconsistent system of equations. So inconsistent means both the equations cannot happen at the same time. These two equations are inconsistent with each other. That is, if I say x plus y equal to 2 and also say x plus y equal to 3, you are inconsistent, right? You're saying two different things. So if you don't have a solution, if the equations have no solution, then we call the system of equations as inconsistent system of equations. And if the equations have a solution, we call them as consistent system. Consistent system of equations. So if you have a consistent system of equations, the equations might have a unique solution or infinite solution. So both these cases come under consistent system of equations. So no solution case comes under inconsistent system of equations. Now this topic deals with how to find whether an equation have a consistent solution, that is, if the set of equations are consistent or inconsistent. If they are consistent, whether they have a unique solution or infinite solutions. So this is the topic which we are going to learn. Now, you already had some introduction to this topic of consistency in your lower classes. So in your 10th class, you'd have learned how to check the consistency of linear equations in two variables. For example, so if you have two linear equations, a1x plus b1y is equal to c1 and a2x plus b2y is equal to c2. So these are a pair of linear equations in unknowns x and y. a1x plus b1y is equal to c1, a2x plus b2y plus is equal to c2. Now, what is the condition which ensures that this equation has a unique solution? So I'm just writing what you have learned in your lower classes. In this topic, let us try to introduce matrix methods to do the same. So the condition is, if a1 by a2 is not equal to b1 by b2, then you have a unique solution. If a1 by a2 is equal to b1 by b2, then you have either of the two cases, that is, either infinite solutions or no solutions. So that depends on the c1 and c2. So if a1 by a2 is equal to b1 by b2 is equal to c1 by c2, then you have infinite solutions. And if a1 by a2 is equal to b1 by b2 but is not equal to c1 by c2, then you have no solution. So you have already analyzed this in your lower classes, where you assume that this and this are straight lines on a graph sheet. So if you draw the graphs of these equations, you get two straight lines. So if this is the case, we deal with two non-parallel lines, they intersect at a single point. So this case corresponds to coincident lines where you have infinite solutions. This case corresponds to parallel lines where you don't have any solution. Now, what we're going to learn is how to use matrix methods to find the consistency of 2 by 2 equations and 3 by 3 equations.